Earlier we have discussed SR NOR latch. Now let us discuss SR NAND latch. That means earlier the memory element is made up of, that is SR NOR latch means you are using two NOR gates in cross coupling. Now instead of NOR gates we will replace by NAND gates. So the next latch is SR NAND latch. So SR NAND latch means two cross coupled NAND gates will form SR NAND latch. So that I am drawing the circuit. You just say this is the first NAND gate, this is one more NAND gate. Okay, this is a NAND gate 1. I am just naming the NAND gates, NAND gate 1, NAND gate 2. The Q bar are the outputs, the complementary outputs. And look at this. So here NAND gate 1 output is connected to the NAND gate 2 input, and the NAND gate 2 output is connected to the NAND gate 1 input. So these type of connections are called as cross coupling, and this cross coupling connections are basically feedbacks, and they will help us to retain the bit, or they will give us memory. And the inputs, and this I am calling as yes, this I am calling as, you can use the terminals wherever you want, you can write yes and R, but the analysis will not change, analysis will be same. Focus on the analysis, not on the names and terminals. Okay, in the sequential circuit there will be a lot of analysis, you should understand the analysis. Okay, now, and mainly the analysis here is pertaining to enable disable concepts, remember this. So understand this enable disable concepts clearly. Okay, the circuits will be very easy. So now, okay, let us make the truth table for this SR NAND latch. This is a NAND gate 1, NAND gate 2, and this is a Qn plus 1. In the truth tables, we will be always interested in the next state what the circuit will store. So the Qn plus 1, the next what it is storing, that is important, and the next states you will get only after giving inputs. Now before giving the inputs, I told you it is called as Qn. So here with the two variables you will have what, 4 different combinations, 0 0 0 1 1 0 1 1. Earlier, now okay, that I am doing. Earlier in the SR NOR latch I told you that if both the gates are disabled, it will enter into what, invalid state. If both the gates are enabled, it will enter into the previous state or hold state. If one is enabled, the other is disabled, it will enter into either set or reset state. The same concept I will be using here, nothing else. So just here NAND gate 1, now S equal to 0, R equal to 0, S equal to 0, R equal to 0 input. So this circuit has two inputs, two outputs. So if both the inputs are zeros, the NAND gate 1, 2 are disabled, D for disabled, this is a notation. We know that any one of the input of NAND gate is 0, then it will be disabled, enable disable concept I am using. So just understand or digest that enable disable concepts perfectly. Things will be very easy in sequential circuits. So NAND gate 1, 2 will be disabled. Why? Because S equal to 0, R equal to 0. Remember, whenever NAND gates are disabled, outputs will be what? Simply they will be 1, and this will also be 1. If NOR gates are disabled, there will be outputs will be 0. So here NAND gates are disabled means they will be what? Simply 1s, complements. Now, see here, earlier if Q equal to 1, Q bar, how Q bar can be 1? What kind of Boolean algebra is this? If Q equal to 1, how Q bar will be 1? Q bar has to be 0 from Boolean algebra. Since it is violating the laws of Boolean algebra, that's why circuit is violating the laws of Boolean algebra. So never give S equal to R equal to 0 for this NAND latch. So, and we say the circuit is entered into invalid or useless state. We call this as an invalid state or forbidden state or indeterminate state. So never give S equal to R equal to 0 for NAND latch, and never give S equal to R equal to 1 for NOR latch. Now just see the next one. Now the next combination is S equal to 0, R equal to 1. If S equal to 0, NAND gate 1 is disabled, NAND gate 2 is enabled. So focus the logic gates which are disabled first. So NAND gate 1 is disabled. If NAND gate 1 is disabled, what will happen is the output will become simply 1. This will be 1. So if this is 1, okay, look at this, this 1 will come here, 1 and 1 complement. So Q bar has to be 0 because both are complements. It's a valid combination, and the output is what? This is the output, Q. This will be always complement. Output means this, you have to consider. That is a Qn plus 1. So it is 1. So this is what? When the device is storing 1, we say the device is in set state. Now if it is 1 0, it will be what? Enable disable. Same thing, it is exactly opposite. So remember, here it will be 0. If one is enabled, other is disabled, either it will be in set or reset state. I told you this, it will be in reset state. You can just check that. And if both are 1 1, remember both are enabled, both the NAND gates are enabled. If both the gates are enabled, it will enter into the previous state, Q1 state. This earlier I told you this, and we call this as a hold state or the previous state. So these three states are valid states, and the first state, okay, for S equal to R equal to 0, the device will enter into invalid state. So here also we will see some sequence of inputs. Just here I will give certain inputs continuously and I will trace out the outputs. Let us say S equal to 1, R equal to 0, then what will be the output? Just here, if S equal to 1, R equal to 0, you are getting Q equal to 0 from the truth table. So this table is called truth table for the NAND gate. Next, if I give 0 1, output will be what? 1. If I give 1 1, it will enter in the previous state. Previous value is what? 1. So next value will be 1. Now if I give 0 0, what will happen is it will enter into invalid state. Now if I give 1 1 again, remember if I give 1 1, don't put invalid state because it's a valid state. Q1 is a valid state. So but exact value you don't know. That depends on the delays of 1 and 2 NAND gates. If you know delays of 1 and 2 NAND gates, you can find out whether Q is 0 or 1. So since you don't know the delays, simply put 0 or 1. It is a valid state. Okay, so remember that. That's so on like this. So this is about the sequence of outputs when S and R are given inputs. And one more thing, okay, is now let us check whether it is an active high or active low latch. So for that, what you do is, see here, set. So when the device is set, let us check the set input. Yes means set input this. Set input is low. You can just hear set input is low. And when the device is reset, when the SR NAND gate is reset means check the reset input. Check the reset input. Reset input is what? 0. 0 means low. Set is low, reset is low. Low. That means this is called as active low SR latch. So why it is called as active low means this is the reason. If set input is low, the device is set. If reset input is low, then the device is reset. So that's why it is called as active low SR latch. Okay, hope this is clear, right? Earlier we have seen SR NOR latch, this is SR NAND latch. So SR NOR latch is active high SR latch and this SR NAND latch is active low SR latch. Now see the simple, now here you have, here I kept S, here I kept R, right? Now in case if you interchange the terminals, in case if you make this S as R and if you make this R as S, swap the terminals R to S and S to R, then the name, okay, then what will happen is the name is the device will be active high SR latch. Okay, the device will be active high SR latch. That's it. So remember the terminals are very important. So look at the terminals and just active high or active low, accordingly you will get. Now, so SR NOR latch and SR NAND latch. So these two latches are called as non-gated latches. Why they are called non-gated? Because there is no control input. So for SR NOR latch or SR NAND latch, there are two inputs S and R and two outputs Q, Q bar. There is no special controlling input for the circuit. So the next circuit is a memory element with a control terminal. So there is the third circuit. There is, this I call as a SR NAND latch. SR NAND latch with control input. SR NAND latch with control input. Remember this. Earlier we don't have any control input. Now I am just adding a extra terminal called as control input apart from S and R inputs. Now how this circuit will be, see here, this 1 and 2 NAND gates. Now I will take the same SR NAND latch and I will connect two more NAND gates and I will pull out the control terminal. Look at here, the same circuit I will take. See carefully. Okay, this is the So this is a NAND latch. This is a basic NAND latch. This is the same thing. NAND gate 1, NAND gate 2. So this is a NAND latch. Now for this NAND latch, the same circuit, I will add 2 more NAND gates. Look at here. Okay, I'm connecting 2 more NAND gates to the previous 2 inputs, and all these are 2 input gates. 1, 2. This I'm calling as 3, 4, and this I will call S. This I will call R. And remember this here. So S and R 2 inputs are there. Now these 2 terminals, okay, this terminal and this terminal I will join together, and I will take out a common terminal, and that common terminal I will call C. Now this C, what I am calling, that is called as a control. The complete operation of that circuit depends on the control. Okay, C is important. So first, out of all the terminals, C is given the topmost priority. After that S and R, after that Q bar outputs. Now the C is called as a control, or sometimes it is called as enable, sometimes it is called as a gate, sometimes it is called as a clock. So whatever it is, okay, in short they will call CLK. Remember this, clock. So clock or control or gate or enable, all are same for a, okay, all mean the same actually. Okay, don't think clock is different, control is different, gate is different, all are same for this circuit. And these 4 NAND gates, okay, in this fashion will form the SR NAND latch with control input. Now let us see the operation of the circuit. This has 2 inputs. You can just 3 inputs. C is called as control input. So C is the first control input. You can just see that, and S and R are the inputs. So now what I am doing is, I am not making this NAND gate 1 and 2, all those things. Directly I am writing Qn plus 1. I am using the enable disable concept, and I am forming the truth table. Now C is a very important terminal. This is a controlling terminal. Okay, this one. Now first let us see what will happen if C equal to 0. If C is equal to 0, what happens is the NAND gate 3 and 4 will be disabled. Enable disable concept, very important. Okay, if C equal to 0, 3 and 4 gates will be disabled irrespective of S and R. If 3 and 4 are disabled, output will be always 1, always fixed to 1. Disable means that only output is always fixed to 1. Now that 1 bits, look at this 1 bits, they are actually going to what? This 1 and 2 NAND gates. This circuit, okay, that 1 and 2 NAND gates will form this circuit. So if I give 1 to this circuit, what I am getting? It is in the previous state, hold state. That means S and R, you give whatever you want. S and R are here for this circuit. Remember this. S and R, you give whatever the bits you want, 0, 0, 1, 0, 1, 1, anything. As long as C equal to 0, NAND gate 3 and 4 are disabled, and output will be always in the previous state. It is a QS state. Okay, it will be always in the previous state or hold state. So very, very important. Now tell me whether the latch is working or not working. Latch is not working. Why? Because as long as C equal to 0, S and R, you give whatever you want, 1, 1, 0, 0, 1, anything, whatever you want, 0, 1, 1, 0, 1, 1. You are giving various inputs, output is always the same value, output is fixed, means it is not working. Okay, that is how we say the device is not working in flip-flops or latches. Output is not changing, means it is not working, that's it. Now let us say what happens if C equal to 1. Look at this. If C is equal to 1, next case, if C is equal to 1, NAND gate 3 and 4 are just here. NAND gate 3 will be simply S bar, NAND gate 4 will be what? R bar. Look at here. This is 1 and S whole bar, that is S bar. 1 and R, okay, so NAND gate 4 will be R bar. So just here. Now C is equal to 1. Now let us take S equal to 0, R equal to, now I'll take S equal to 0, R equal to 0. S and R are here, remember, S and R are here. So if S equal to 0, R equal to 0, S bar, R bar will be what? 1, 1. That means for NAND gate 1 and 2, if I give 1, 1, what will happen is, okay, it will enter into a hold state again. It's a Q and hold state or previous state is one and the same. Okay, so it will enter into a hold state, or you can call previous state, the same word. Now C is equal to 1, I will fix C equal to 1, I will not change the C, and I keep on changing the S and R inputs. Next is 0, 1. if S is 0, R is 1, S bar, R bar will be 1, 0. That means I am giving to, okay, if I give 1, 0 for this circuit, this is SR. If I give 1, 0, remember it will be reset. Simply the same circuit. It is entering into a reset state. Next, similarly, if it is 1, 0, it will be set. So this is a set state. Now see the last one. If S equal to 1, R equal to 1, S bar, R bar will be 0, 0. 0, 0 means NAND gate 1 and 2 will be disabled. So if these two NAND gates are disabled, it will enter into a forbidden state or an invalid state. So never give S equal to R equal to 1 for this circuit or for this circuit. Or for this circuit, S equal to R equal to 0. For that circuit, S equal to R equal to 1, you don't give. Now, the problem with this circuit is never give S equal to R equal to 0. For that circuit, the problem is S equal to R equal to 1. Never give that S equal to R equal to 1 because it is entering into invalid state. Now, let us check whether it is active high or active low latch. So, just here when it is reset, check the reset input. Reset is high. Okay, when the device will enter into set state, when the set input is high. So, this circuit is an active high SR. Okay, active high SR latch with control input. Active high SR latch. Of course, with a control input, no doubt. Now remember, this latch will work when C equal to 1 normally. If C equal to 0, the output is always the previous state. It is not working. So if I want to maintain the same state, okay, or the same output for the circuit, make C equal to 0 and just leave the circuit. Now, so this is the truth table of a SR NAND latch with control input.